Welcome back. Now we are proceeding here in lecture number 31. Here we solve a gate problem in which we have to find out current in 10 ohm resistance. So here there is two resistance which have the same value of the resistance 10 ohm. So we have to find out in both the resistance the value of current. So now we start our problem. So this is our problem. Now first of all we look our problem here. There is two current source here. Now when we choose the method in KVL, basically we cannot apply the equation of KVL if any branch consisting current source. So means in this mesh or closed path we cannot apply KVL. In this mesh again we cannot apply KVL, and in the whole loop we cannot apply KVL. So there is just one mesh in which we apply KVL. So to solve this question I use both method, means we are using here KVL and KCL method. We assuming both method simultaneously. So first of all, as per our nodal analysis, there is a branch in which resistance is not present. So we use super node. Let us say first of all we assume the current distribution in every branches. Let us say this is I1, this is I2, this is I3, this is I4, this is I5, and this is I6. Now after assuming the current, we apply super node at these two junctions. So I write these junctions here. This is I1, I2, and this is I4 and I5, and in I3 for this 5 ampere source we assuming invisible. So now by taking these two nodes at super node, like here, so this is I1, this is I2, this is I4, and this is I5, and apply KCL, means summation of all incoming current is equal to summation of all outgoing current. So what is the incoming? I1, and what is outgoing? I2, I4, and I5. So is equal to I2 plus I4 plus I5. So in this way we can write this equation in term of all the current I1, I2, I4, and I5. Similarly, we can also assume super node at this point and this point. Let us say this is X, this is Y, and this is Z. So now we apply Z, and let us say this is P. We apply super node at point Z and P. This is Z point and this is P point. So this is I1, this is I4, this is I2, and this is I5. So at this point we assume these two nodes at one point. So this is I1, I4, this is I2, and this is I5. Again apply KCL, means summation of all incoming current is equal to all outgoing current. So here outgoing current is I1, and what is the incoming current? I4, I5, and I2. So I2 plus I4 and I5. So in this way we find these two equations similar. So you have to choose any node here and treat it as super node. Any two nodes and treat it as super node. Now we assuming apply KVL at X, P, Z, Y, and Z in an X, P, Y, Z, and X. So current is flowing in this direction. This is positive, this is negative, this is positive, this is negative, this is positive, this is negative, and here this is positive and this is negative. So in this way we assume our polarity as per our previous convention. Now apply KVL and start from Z. So start from here, minus of 10 I1, here minus of 20 I2, here plus of 10 I5, and here minus of 20 I4 is equal to 0. So after solving this equation, we can write this minus of I1 plus I5 is equal to twice of I2 plus I4, or in this way we can write 3 I1 is equal to 3 I1 I5, and we can say 3 I1, this is minus of I1 plus I5 is equal to I2 plus I4. So I2 plus I4 we can write I1 minus I5 twice of I1 minus I5. So in this way we can write 3 I1 is equal to thrice of I5, and we can write I1 is equal to I5. So now putting I1 is equal to I5 in this equation, so we can get I2 plus I4 is equal to 0. After solving, it would be I2 is equal to minus of I4. So here we derive again one of the equation. Now apply KCL. Apply KCL at point X here. So incoming current is equal to all outgoing current, means I1 is equal to I2 plus 5. I1 is equal to I2 plus 5. Similarly, apply KCL. Apply KCL at point Y here. I3 is equal to I4 plus I5, and the value of I3 is 5, means 5 is equal to I4 plus I5. 5 is equal to I4 plus I5. Again apply KCL at point Z. So what is the value of Z now? Here I4 is equal to I1 plus I6, means I4 is equal to 10 plus I1. So we derive three equations here. This is one of the equation, and this is the equation, and this is the equation. Now from this equation, I4 is equal to 10 plus I1, and put the value of this I1, means I2 plus 5. So here we derive I4 is equal to 15 plus I2, and we know that I2 is equal to minus of I4. So this is minus of I4, and here I4. So twice of I4 is equal to 15, and I4 is equal to 15 by 2. This is 7.5. When we know that I4 is equal to 7.4, so we can write I2 is equal to minus of I4, means we can say minus of 7.5 ampere. Now we get I4 and I2. Now in equation number this, we can write I1 is equal to I2 plus 5. So what is the value of I2? Minus of 7.5 plus 5 is equal to minus of 2.5. Similarly, from this equation here, 5 is equal to I4. I4, what is the value of I4? 7.5 plus I5. In this way, we can write I5 is equal to minus of 2.5 ampere. So in question, we have to find out the current in 10 ohm resistance, that will be I1 and I5. So this is I1 in 10 ohm resistance and this is I5 in 10 ohm resistance. Both values are same, means minus of 2.5. So in this way we have to solve this gate problem and find out the current in I1 and I5 is minus of 2.5. In next lecture we can solve again some gate problems. Thank you.